Hello everyone, I'm Deblina Chattopadhyay
And I'm Avijit.
and we are Team Zero Hour and we are presenting our project in Are You Hacking 2022. Our problem statement that we are focusing on is when an accident happens in two-wheelers, an emergency alert SOS will be sent. Uh, and for that, we are making this compact device that connects the two-wheeler with the emergency services and their family members, even if they are unconscious, so that help can reach them on time. Our solution approach is such that the sensors detect the irregularity of motion caused due to the change in axis on the occurrence of the accident. Then this analog value is sent to the microcontroller for further analysis and to be acted upon. The sudden abnormality in data during the case of an accident acts as a trigger that indicates an accident condition has occurred. Then the microcontroller reads the location information from the GPS and connects to the Twilio registered account by the Wi-Fi network, which can be easily connected via mobile hotspots. Using the Twilio API in the microcontroller, it performs a sequential messaging of the numbers predefined in the program. However, in the future, we will try to build an application on the phone that reads the published data, and upon an accident, it sends SOS to the family members and to the nearby emergency services by calculating the nearest one, which are stored in the phone itself. Along with that, it performs voice calls, one a priority queue.
So the working model here is given by this block diagram. Here is a Wi-Fi microcontroller we're using, and that's the ESP32. And for the location of latitude and longitude, we are using a GPS module. And to read the acceleration, like the sudden jolt that happened due to the accident, for that we are using an accelerometer to measure that acceleration. When an accident occurs, it is usually that seen that the acceleration goes up to 16 g to 28 g's, and that happens most of the times. So here the accelerometer will measure that jolt in acceleration like around 16 g's. Then the microcontroller will read that signal from the accelerometer, and since the GPS is constantly sending the latitude and longitude, the microcontroller then connects to the Twilio account we have registered into the Twilio account, and from there we call the Twilio API to send the messages here right now to our predefined phone numbers. Goals achieved so far are like we have made the prototyping model, which consists of the ESP32, the GPS, and the accelerometer, the main unit. So, and the hardware manufacturing, like if we go for a PCB design, the hardware manufacturing will be within $10. We estimate that, since the we are using very inexpensive items here right now, like the so yeah. And these demanding in our government here, it's very demanding this kind of devices. They are demanding this kind of devices by young innovators. The component we have selected, we also selected which components we are going to use for at a production level basis for the phase one. Yeah, and we completed our PCB design. That's the goal achieved. The tech stack we have used are here the ESP32, the Wi-Fi microcontroller, and group accelerometer, which is the acceleration measurement unit, and software. These in the software part, we are using RTOS here, since it's very necessary to read the acceleration data and read the GPS data, and whenever this accident happens, we need to send the message at that instant only. So it's very important to have a multitasking operational system. So we are using RTOS here, and the Twilio API. Of course, the Twilio API is the most important service we are using here to send the messages from our ESP32 microcontroller.
These are the features that we are trying to achieve, but I'll come to these later. First, let's move on to the demo.
So here we have the ESP32 microcontroller along with the accelerometer. I have taped it in for it doesn't roam around. I mean, and here is the GPS module. So it's basically it's connected to the satellites. So that's why it's blinking here as well. Yeah, so that indicates that it is connected to the satellites and it's acquiring the data properly, the latitudinal and longitudinal data. So what I'll do here, I'll try to emulate the action of an accident by throwing this microcontroller, this setup, just to show that it had an accident. Now this threshold can be set up by the custom user. So okay, for the demo, like I'll show you by emulating by throwing this setup, and it will then send the message to these two predefined phone numbers, which here you can see like these two phone we have kept here. So the message will receive on those two phones. So let's give this a try. Like I'll try to throw this up. So this happened, and we'll wait for the messages. Yeah, we can see that one message has received where it says that yeah, here Avijit had an accident at location. That's my location actually, and we had the accident here right now. Similarly, to the left phone, we can see that another message is there. Yeah, here we can see that this message has been received by them. We can try it once more time, and it going to happen again. But like this, yeah, as you can see, as soon as this accident happens, it sends the message there. Yeah, so I hope you all like this project, this purpose. So here we are trying to emulate actually, but in real time, as I have said, mentioned that for an accident, the acceleration goes above that 16G. And as well as like, since we are using an accelerometer, when it won't happen here, we are showing you directly by throwing it, but when it's in real time, when it will be in a two-wheeler, the two-wheeler will be accelerating, so it will have a constant velocity or some acceleration. So by that way it will know that okay, I am in a two-wheeler, I'm not just standing somewhere, and suppose I it unconditionally it fell from my hand, so it won't trigger that time. It will trigger only when you are in a two-wheeler, you are moving, and this suddenly you have this accident and that acceleration goes above that 16G, and that time you trigger these messages, you send these messages to the emergency contacts and the emergency numbers like the ambulance or something like nearby ambulances. Yeah, so
Now, the features that we are trying to achieve are jolt detection on falling or other accidental occurrences, the GPS feature, which is used for acquiring the locational coordinates, that is the lat and longs, connected custom app with emergency message sending capabilities on accidental situations, sending of data to the closest police stations, hospital, medical units, and 5 emergency contacts saved by the user itself. Pre-recorded automated call sending feature using the app to priority contacts so that they know what has happened. Additional directly including all public emergency contacts as per their coordinates readily available in the app for offline access in case there is no network in the area the victim is traveling. Compact module like controller designed for ease of manufacturing and effective usage as well. We hope you liked our project. Thank you for watching.